Before we actually start with some examples of how to determine the equation of a line from a table, here's first some information. Let's first identify that the table does in fact represent a linear equation by looking for a constant rate of change, a constant slope. Now the constant rate of change does give us the slope of the line, the change in y over the change in x. Then we say, do we see an ordered pair of the form 0b? If we do see an ordered pair of the form 0b, then we can go directly to the slope-intercept form, the y equals mx plus b form. And if not, then I will go through the point slope form and then convert to slope-intercept. So here's our first example. Does the table represent a linear equation? And if so, write the equation in slope-intercept form. So if we look at the changes in x and y as we go from one point to the next, here we have an increase of 2 consistently across the table, and we have an increase of 3 for the y. And so the ratio of the change in y to change in x, change in y over change in x, is equal to 3 over 2. And that's the slope. We also see the ordered pair 0, 10. And so the b is equal to 10. So therefore, the slope-intercept form of the equation of the line would be y equals 3/2 x plus 10. Exercise 2. Same question. Is it linear? And if so, let's put it in a slope-intercept form. Alright, well the x's increase by 5s consistently across the table. Then looking at the y's, we first have a change of 2, then a change of 4, and then a change of 8. And so the change in y over the change in x, the rate of change is not consistent. Alright, so delta y over delta x is equal to 2/5, then 4/5, then 8/5. This is not linear. Alright, so when we see something like this where there is not a constant rate of change, it is not linear, we cannot write a linear equation that models the table. Alright, now if we look at exercise 3, here in our table of values, if we aren't careful, we might say, well, this isn't linear, because if we look at it and say, well, first we're increasing by 4, and then we're increasing by 8, and first we're decreasing by 3, and then we're decreasing by 6, this doesn't look linear. It doesn't look like the previous ones. But if we consider the rate of change, if we consider the delta y over delta x, the change in y over change in x, for the first one we have negative 3 over positive 4, which we can write as negative 3/4. But then we have delta y over delta x is negative 6 over positive 8. Well, that reduces to negative 3/4, which is the same as what we had in the previous one. So we do have a constant rate of change, and we can say that m is equal to negative 3/4. Again, we see an ordered pair 0 something, so b is 12, and so we can write that y equals negative 3/4 x plus 12. Exercise 4, same instructions. Well, here our x's are increasing by 8 across the table. Our y's are increasing by 3 across the table. So that looks good. So we know it's linear. And in fact, we know that the delta y over delta x is positive 3 over positive 8, 3/8. And that's our m value. But the problem is we don't have an ordered pair 0 something. So here's where I like to go through the point-slope form, which I'll write again is y equals m by x minus x1 plus y1. And I'm just going to use the ordered pair negative 15, negative 4. I could really use any of the ordered pairs. So then what I'll write is y equals 3/8, that's the m, by x minus, the x1 is negative 15, plus the y1 is negative 4. Cleaning this up a little bit, I have 3/8, y equals 3/8 by x plus 15 minus 4. This is a linear equation that represents the line. However, it's not in slope-intercept form. It's not in the mx plus b form. So what I will do is apply the distributive property. So I'll have y equals 3/8 x plus 3/8 times 15 is 45/8. Now I know I've got to get, I need to subtract 4 here, but if I'm thinking ahead, let me think of that 4 as a 4 over 1 and find a common denominator. So I'll multiply both numerator and denominator by 8, and that's 32 over 8. So I have 45/8 minus 32/8, and simplifying, I have y equals 3/8 x plus 13/8. Alright, one more here. Same instructions. Alright, so here we have an increase of 6 and then an increase of 11. And from 75 to 67.5, that's a decrease of 7.5. And from 67.5 to 53.75, that's a decrease of 13.75. Alright, so let's check and make sure that the delta y over delta x comes out the same. Alright, so delta y over delta x is negative 7.5 over 6, which is negative 1.25. Use a calculator if you need to. Checking the other delta y over delta x, we have negative 13.75 over 11, and if you do check this on your calculator, we have negative 1.25. So our m is negative 1.25. Using the point slope again, I don't see an ordered pair 0 something. So I'll use the ordered pair 475, and I would write y equals negative 1.25 by x minus 4 plus 75. Applying the distributive property, I have y equals negative 1.25x plus 5 plus 75. So y equals negative 1.25x plus 80, and that's the slope-intercept form.